Today we're going to start our section on systems of equations. So a system of equations is a set of equations that have the same solution. What does a system of equations look like? So an example of a system of equations is when we're having a set of equations such as 2x plus 3y equals 10. And another equation that uses the same variable, such as 5x equals 17 minus 4y. Same equation, or equations that have the same variables. A non-example would be something like if I had 3x plus 4y equals negative 9. And my second equation might be m equals 4a minus 2. Different variables, not using the same variables, so that is a non-example of a system of equations. What does it mean to solve a system of equations? That means find the solution that makes each of the equations true at the same time. When you find that solution, you're going to write it as an ordered pair, x comma y. It is a point on both graphs. There are three different ways that we're going to talk about solving a system of equations: graphing, solving by substitution, and solving by elimination. When we're looking at substitution and we're looking at elimination, these are the two methods that we are going to solve algebraically. All three of these methods are reviewed from 8th grade Algebra 1. Today we're going to focus on solving by graphing. So let's first get started in graphing. When I have a system, I would recommend using two colors to do your graphing of your lines. So first equation, y equals x. When I take a look at that equation, pick a color, maybe put a dot in front of it so that you know what color you are using to graph. So y equals x. This equation is in slope-intercept form, y equals mx plus b format, so we can grade accordingly. So here, m, my slope, is represented by 1. My y-intercept, there is no b at the end, so my y-intercept is b, 0, 0. So graph. So remember, we begin with my y-intercept at 0. I move my slope. My slope is 1. Think about making it a fraction, putting it over 1. So rise 1, run 1. Rise 1, 1, 1. And we can do that throughout my graph in both directions. I can come down 1 and back 1. Okay. Putting all of those points on my graph. Then use your straight edge and draw in your line for your equation. Now we're ready for equation number 2. Switch colors. That will help keep your work a little bit organized. Notice this second equation, 6x plus 2y equals 16, is not given to us in slope-intercept form. So to graph it, we need to first put it into slope-intercept form. Means we need to solve our equation for y. So if we're going to solve our equation for y, I need to subtract 6x from both sides. So 2y will be negative 6x plus 16. Divide each term by 2. So y will be negative 3x plus 8. So my slope this time is negative 3. My y-intercept is 8, so that is the point 0, 8. Now we can graph. So 0, 8 is my y-intercept. Slope of negative 3, put it over 1 so it's a fraction. So rise negative 3, so go down 3, run 1. 1's positive, go to the right. Down 3, run 1. Down 3, run 1. And so on. Down 3, run 1. Now you can use your straight edge to draw in your line. Don't forget, this is only a portion of the line that's fitting onto this graph. So make sure that you put the arrows on the end to show that it keeps extending beyond the focus of this graph. Now we want the solution to this graph. The solution to this graph is the intersection of these points, the point that is in common to these two graphs. So where does it cross? These two lines intersect or cross right here, and that is the point 2, 2. So 2, 2 is the solution to that system. So I should be able to substitute 2 in for x and 2 for y, and I should get 2 true equations. So 2 equals 2. 6 times 2 is 12. 2 times 2 is 4. 12 plus 4 is 16. It works in both equations. So I know that is the correct solution. Now we all have graphing calculators. How could I use my graphing calculator to be able to solve that system? Okay. So first we're going to graph each equation on my graphing calculator. So grab your graphing calculator and we're going to graph them. So if you have equations in here, clear them out. Okay. Up here in equation 1, we're going to graph y equals x. In equation 2, notice I can't put it in the way I see it. I have to put in the form y equals. So my second equation is y equals negative 3x plus 8. So negative 3x plus 8. Graph. I can always zoom 6 to go back to standard. And now we see the intersection. Okay. I might be able to read this one off my graph as 2, 2, but if I want the calculator to tell me how to see the graph, see that point of intersection, make sure first we see the intersection point in my graph window display. If not, adjust the window. Now for the calculator to tell me where that point of intersection, we're going to press second calc. Number 5 is intersect. And then we can scroll to the point of intersection and press enter 3 times. So what that's going to look like, we're going to second calc. Number 5 is intersect. First curve, hit enter. Second curve, hit enter. Guess we're going to hit enter. And then the cursor will jump right here to the point of intersection at 2, 2. So the point of intersection is 2, 2, exactly what we found when we graphed it. Okay. Let's try a second equation. Y equals 2x plus 12, 5x plus y equals 20. First thing I notice, second equation is not y equals, so I'm not going to be able to enter this one into the graphing calculator until I solve for y. So I'm going to subtract over the 5x. So y equals negative 5x plus 20. Now I'm ready to enter them into my graphing calculator. So I can graph by hand or I could use my calculator. So I'm going to clear out what I have in here. First equation, y equals 2x plus 12. Second equation, y equals negative 5x plus 20. Graph. I don't see the point of intersection, but looking at the lines, it looks like it's going to be somewhere up above. So I need to change the window display. So the x's look okay, but the y's I need to go higher. So I need to go higher on the x. So I'm going to hit window. And my y max, I need more y's. So I'm going to scroll down. And my maximum y value, I have to go higher. I'm going to try something, I don't know, 30 maybe? And then try graphing, and let's see, do I see the point of intersection? Ah, I do, good. So now we can try finding the point of intersection. So second calc, number 5 for intersection. First curve, enter. Second curve, enter. Guess, enter. And notice this time that point of intersection is a decimal. Okay, so we're going to round to 3 decimal places. So that was 1.143, comma 14.286. So reading that point of intersection off of your graphing calculator directly. Now, when we graph, what can happen? Okay, so flip back 2 pages in your packet to the 3 types of solutions to systems of equations. So the first thing, there's 3 things that can happen. When I graph, we've already seen the first case, the lines can intersect. So I graph line 1, I graph line 2, and the lines intersected. When that happens, they intersect, the points cross over, and we name that point of intersection. That gives me one solution to that system. That's the first thing that can happen. That was the first 2 examples we had taken a look at. But that's not the only case that can happen. The next thing that's possible, the lines could be parallel. So I can graph my first line, and then when I go to graph my second line, it graphs in such a way that it is parallel to the first. So when they are parallel, these lines will never intersect, so it's not going to have a solution. So in which case, we have no solutions. When I get to solving them algebraically, what's that going to look like? Both variables will cancel out, so I'm not going to have an x or a y left in my equation, and my remaining equation is going to be false, meaning I'm going to end up with something like 7 equals 0 or 15 equals 6. So some equation that is not true. When that is the case, the lines will be parallel and we will have no solution. The third and final case is when I graph one line and the lines will coincide. So I graph one line, and now when I go to graph the second line, it coincides. I graph it and it falls right over top of the first line. In which case, every point that was on the first line is also on the second line. So we're going to have an infinite number of solutions. What is that going to look like algebraically? Well, the variables are still going to cancel out. I'm going to have no x's and no y's left in my equation, but that remaining equation is going to be true. It's going to happen every single time. So you're going to get something like 5 equals 5, or 17 equals 17, or -7 equals -7. Okay. We'll explore how to solve these algebraically in the next 2 videos.